Good morning, students. Welcome to the course Retrofitting and Rehabilitation of Structures. Today, we will be moving on to the second lecture of the third unit. The third unit is Condition Assessment, Non-Destructive Testing and Evaluation. And this is the second lecture. And the topics that will be covered in this lecture are Introduction to NDT, Situations and Context where NDT is needed, classification of NDT procedures, and we will discuss visual inspection. Now, if you know, visual inspection was the third stage of condition survey that we discussed in the last lecture. But visual inspection is taken also as one of the fundamental NDT procedures. So the major portion of this lecture today will be dealt with visual inspection. So, introduction to non-destructive testing of concrete. Now, importance, it is often necessary to test concrete structures after concrete has hardened to evaluate its performance for its designed use. Such testing should be done without damaging the concrete. So, the concrete has to be tested after the structure is built, after say many years, 3 to 5 years. Now, we have to ascertain the strength of the concrete without damaging the concrete structure. So that is when non-destructive testing is used. There are different types of tests of concrete. One is tests in its fresh state, which we do in our concrete laboratory. Then we do partially destructive tests in its hardened state, and of course fully destructive tests also. When we do quality assurance of concrete, we cast concrete cubes and we completely damage the concrete cubes to identify the compressive strength. Apart from that, for the structure itself, on the structure itself, in the hardened state, there are some partially destructive tests, and finally we have non-destructive tests in hardened state. So today our topic of focus now is non-destructive tests. So what is the scope of non-destructive tests? The scope of non-destructive tests is to check the quality of workmanship, to check the structural integrity and serviceability, and also to check material deterioration. In a very short and crisp manner, this is the scope of non-destructive test. Whether the workers have done proper job or not, through non-destructive test we can find out. What is the strength of the structure, structural integrity. Structure had been designed for a particular to bear particular load, expecting that the structural members will have a particular strength. So whether the just a second. Yeah. So whether the structural integrity is maintained or not, and then serviceability of the structure. Serviceability in the sense whether the cracks within the structure and the deflections within the structure are within the prescribed limits as per the IS code. And then through non-destructive tests we can also identify material deterioration, whether concrete has deteriorated or is it in good condition, based on all the mechanisms that we have studied in the previous units. So situation and context where NDT are needed. So typical situations where non-destructive testing may be useful are as follows. For quality control of precast units or construction in situ, removing uncertainties about the acceptability of material supplied owing to apparent non-compliance with specifications. So non-destructive testing can be done directly on the materials, steel for example, and certain other members. Then confirming or negating doubt concerning the workmanship involved in batching, mixing, placing, compacting or curing of concrete. This should be 4, 5, 6. Monitoring of strength development in relation to formwork removal, cessation of curing, pre-stressing, load application or similar purpose. Location and determination of the extent of cracks, voids, honeycombing and similar defects within a concrete structure. Determining the concrete uniformity, possibly preliminary to core cutting, load testing and other more expensive or disruptive tests. So many. Now, determining the position, quality and condition of reinforcement. We have to identify reinforcement location without damaging the concrete. So an NDT will be useful for that. Increasing the confidence level of a small number of destructive tests. Determining the extent of concrete variability in order to help the selection of sample. Locations representative of the quality to be assessed. Confirming or locating suspected deterioration of concrete resulting from such factors as overloading, fatigue, external or internal chemical attack or change, fire explosion, environmental effects. Then assessing the potential durability of concrete, monitoring long-term changes in concrete property, and providing information for any proposed change of use of a structure for insurance. Situations where NDT is an option to consider for investigation of in situ concrete. To investigate the homogeneity of concrete mixing, lack of grout and post-tensioning ducts, to determine the density and strength of concrete in a structure, to determine the location of reinforcing bars and the cover of the bars, to determine the number and size and diameters of reinforcing bars, to determine the extent of defects such as corrosion, to determine the location of inbuilt wiring, piping, ducting, etc., to determine whether internal defects such as voids, cracks, delaminations, honeycombing, lack of bonding with reinforcement bars exist in concrete, to determine if there is a bond between epoxy bonded steel plates and concrete members. So these are the various scopes and possibilities of using NDT tests. Now, NDT tests can be broadly classified as into these 4 categories. This categorization is based on this author, Peter H. Emmons. He is a very renowned author who has worked on non-destructive testing and rehabilitation and retrofitting of structures. So this has been co-authored in Indian context by Dr. Sabnis from Mumbai. So both of them together have written this book, Concrete Repair and Maintenance, Galgotia Publications, New Delhi. So this classification is based on this book. So if we closely look at this classification, so concrete, the testing methods can be categorized as tests for identifying mechanical properties, tests for identifying chemical makeup, tests for identifying the physical conditions of concrete, and tests for identifying the external manifestation or behavior of the structure. So within the mechanical properties, we have compressive strength determination using core testing, Windsor probe, rebound hammer. You have quality of concrete by ultrasonic pulse velocity, tensile strength of concrete either using pull-off testing or split tensile strength. Then you have flexural strength, abrasion resistant, and bond strength, pull-off testing. So some of these like flexural strength and split tensile strength are destructive tests. Even core testing is partially destructive tests. Meaning these are some of them are non-destructive tests. Windsor probe, rebound hammer, ultrasonic pulse velocity. Okay. So flexural strength determination generally is based on flexural testing machine. That's also a destructive test. So in determining mechanical properties, mostly we have to deal with destructive and partially destructive tests. but there are few non-destructive tests like Windsor probe, rebound hammer, ultrasonic pulse velocity test. Next, for chemical makeup, for electrochemical activity, for corrosion, if you remember unit 2, how corrosion takes place, the phenomena of corrosion. So to identify the electrochemical activity, we have half cell potential, electrical resistivity. Then to measure carbonation depth, we have acid-base indicators, that is phenolphthalein solution, simplest of tests. Then petrographic analysis, X-ray diffraction, infrared spectroscopy. These are increasingly costly tests, but simple lab test is acid-base indicators. Then alkali aggregate reactions, we have again petrographic analysis, uranyl acetate fluorescence method, and then chloride content determination. This is chemical makeup. For physical condition, for checking uniformity, we have petrographic analysis, ultrasonic pulse velocity test, Windsor probe test, rebound hammer test, and also core cutting. Then you have tests for identifying air void system and so on. Now there is another classification. There is another classification of NDT methods. This is based on the CPWD handbook on repair and rehabilitation of RC buildings. So these are the 5 methods. These are the 5 categories. One is in situ strength of concrete, chemical attack, corrosion activity, fire damage, structural integrity, and soundness. This is the categorization. Now, we have in situ concrete strength. In that we have again rebound hammer. So this is same as the mechanical properties determination as in the previous classification. So you will have similar test: rebound hammer test, ultrasonic pulse velocity test, Windsor probe test. These are non-destructive. Then these are partially destructive tests: capo and pull out tests. Then you have core cutting and lab testing of course, and then you have load test to identify the deflections. For chemical attack, we have carbonation test, chloride test, and sulfate test to be done in the laboratory. Then corrosion potential assessment. We have for corrosion potential, first of all identifying where the reinforcement is. So we have cover meter or profometer measurement. This is an in situ test. Then we have half cell corrosion potential method. So this is a very important test to identify corrosion potential. Then we have resistivity meter, then permeability test, then fire damage and assessment. In the previous classification, this was not so specific. This was not mentioned, but this is an important categorization. Fire damage assessment, thermogravimetric analysis, differential thermal analysis, and X-ray diffraction. So all these are laboratory tests, if you can see. So all these are laboratory tests. That means samples are collected from the damage site, and these samples are sent to the laboratory. Then we have structural integrity and soundness assessment, ultrasonic pulse velocity, radiographic methods, impact echo methods, and there are so many more tests we will discuss in great length. So this is about NDT methods and their classification. So there are so many tests, we can classify them in any of the categories. So important is to remember the categories. Once we remember the categories, automatically based on the test, we can put the test into one category or the other. So next we move on to non-destructive testing by visual inspection. So visual inspection is the most important of all the non-destructive tests. This is the first test. This is part of our third stage of condition survey. In the fourth stage comes field and laboratory testings, which include non-destructive testing. But in the third stage itself, we need to identify through visual inspection, a thorough inspection of what are the tests that we need to conduct. See, non-destructive testing equipments and some partially destructive testing equipments, they are not freely available. We may have to hire it from some contracting companies, or we may have to purchase some test equipments. These are all very costly affairs. So unless those particular tests are useful, there is no meaning to do those non-destructive tests. So for that, a thorough visual inspection is a must to plan for the next phase of testing. So this is the third stage of condition survey. Fourth stage is field and laboratory tests. So this is an important one. So visual inspection, this is the most important of all the non-destructive tests, provides valuable information to the well-trained eye. This is very important. This is for a well-trained eye. And then visual features related to workmanship. Just a second. Visual features related to workmanship, structural serviceability and material deterioration. Then extensive information gathered from visual inspection gives preliminary indication of the condition of the structure. Sorry. And very important is it allows formulation of a subsequent testing program. So this is visual inspection. Now very important is this visual inspection is not confined only to structure being investigated. It also includes neighboring structures, the surrounding environment and climatic conditions. So even minor observations cannot be omitted. For example, um, suppose it's an offshore structure and the deterioration is caused due to the offshore environment. Offshore environment, you know, the near the ocean or a water body, water may be mixed with salts, and during construction phase itself, the water that might have been used might be, high content of salts, which cause the deterioration, and the surrounding weather conditions they affect. So if for this building, if there is some deterioration, a thoughtful visual inspector will come out of the building and also observe the neighboring buildings. If the pattern of deterioration is similar, then we can conclude that environmental effects and climatic effects are influencing this deterioration. Otherwise, if they are dissimilar, if the deterioration in other buildings is not the same as deterioration in the building under examination, then there is not much climatic influence and surrounding environmental effects. So visual inspection, one very important thing is this statement: I see no more than you, but I have trained myself to notice what I see. This statement, yeah, I see no more than you, but I have trained myself to notice what I see. This is actually Sherlock Holmes' statement to Watson in the fiction novel. The point is, everybody observes the building, but it is a trained engineer who notices what the damages and defects are. Untrained engineer cannot notice that. So that is what visual inspection is. It requires training. Next. Now, for visual inspection, it is not that one goes empty-handed. One has to carry some basic tools and some equipments. So, what are the things that must be carried by a visual inspector onto the site? First, so a complete set. Yeah. So, a complete set of relevant drawings showing plan views, elevations, and typical structural details must be carried and carefully studied. So, in the planning stage itself, we discussed in the previous lecture that the relevant drawings have to be collected, and before a visual inspector goes to the site, he has to carefully study all the relevant drawings, architectural drawings, the structural drawings, and finally the built-in drawings. That means if there are changes from the architectural and structural drawings, the final build drawing must also be considered. Now, in additions, some or all of the following may be required: measuring tapes or rulers, this is a must practically speaking. Some markers, very important. Thermometers, anemometers for measuring temperature, pressure, so on. Binoculars, telescopes and boroscopes. Endoscopes or more expensive fiberscopes. Okay. Crack width microscope or a crack width gauge. So to note down the crack widths. Magnifying glass or a portable microscope, good camera with necessary zoom and micro lens and other accessories. So this is what a visual inspector may need to carry. Now, general procedure for visual inspection. So first is one has to familiarize with the structure. He should carefully study the building drawings, plan and elevation, in both plan and elevation. Then he should study the past history, the methods and dates of construction, materials used, construction records, details of past testing and inspections. So past history must be studied. Estimate the use of the structure, current and past usage. Whether the structure was used as per the design estimations or it was overused or underused. This has to be determined. Evaluate the surrounding environmental conditions, conditions of the adjacent structures, environmental and weather conditions. Then examination, careful observation and examination of building surface like structural elements, joints, expansion joints, bearings, drainage channels and so on for structural and non-structural defects. Taking notes, noting down the observations supplemented by sketches and photographs. An assessment report, assessing the observation and recommending the further course of action either for further non-destructive tests or partially destructive tests and repair works. So these are the general procedure for a visual inspection. It's standard and straightforward. Now, defects that are commonly need recording include cracking of various types, depending on the causative mechanism. Then surface pitting and spalling, surface staining, differential movements or displacement, variation in algal or vegetative growths, surface voids, honeycombing, bleed marks, constructional and lift joints, efflorescence, and so on. So some of the common sketches. So now the equipments that a visual inspector must carry, what is the procedure, okay, and now what are some of the common sketches and photographs a visual inspector will have to take. These are some examples. We'll quickly go through this. So, sketch of a surface appearance when concrete has been mixed for too long or time of transport has been too long. That means already initial set has taken place before concrete is placed. So there will be a lot of improper non-homogeneous cracking. So this is a picture. Then sketch of crack due to concrete settling crack. This is a example. Then sketch of exposed aggregate and concrete. Of course, these days we have good quality cameras available very easily. So, and even mobile phones have cameras. However, a good quality camera has to be taken, and the sketching may not be necessary now, but this was the standard process of inspector making sketches. So sketch of exposed aggregate and concrete. Then unsuitable processes at construction joints. That means at joints when forming and formwork and placements and removal of formwork, if they was not done properly, then there may be cracks that are developed close to the joints. Then sketch of cracking due to bowing of formwork. When formwork bends due to in the form of a bow due to swelling of formwork, then cracks may develop. So this is a sketch of cracking due to shrinkage of timber. So timber is part of the formwork, and suppose sinking of timber, not shrinkage of timber, sinking of timber. So the formwork, if it is not properly placed, with proper supports like proper shores, and this particular formwork tilts and there is a crack. So we'll have to mark it this way, representation. Then sketch of severe rusting of reinforcement bars due to chemical action. Then sketch of effect of fire on concrete. Then cracks due to differential settlements of the central column. So central column is settling. So there will be number of differential settlement, bending moments will be developed. There will be shear cracks here, and there will be bending cracks at the top. Then cracks due to bending and shear stresses. For bending, cracks will occur in the midspan usually. Cracks due to bending stresses will occur in the midspan, and they will be perpendicular to the base surface. They will be perpendicular. Whereas shearing cracks will be inclined at an angle of 45 degrees, and they will be close to the supports of the beam. That means it may be either column, close to the columns. That means the end of the beam span. Then cracking of beams and columns due to earthquake. After a post-earthquake, if you want to represent, you have to represent this way. Then cracks due to insufficient reinforcement bars. At the bottom of a slab, this is the cracks that is shown. Cracks due to abnormal set of cement. This is another crack patting. Then sinking of concrete. Concrete sinks, and then this is your plastic settlement type of crack. And rusting of reinforcement bars. Effect of heating and freezing cycles. Chipping. Change of ground conditions, low temperatures and dryness. There are some patterns that visual inspectors follow. Effect of atmospheric conditions. Non-uniformity of admixtures. Pop out due to reactive aggregate and high humidity. Some aggregates are getting popped out. Then some plastic settlement cracks, parallel cracks along the line of reinforcement. Then you have plastic shrinkage cracks, and then you have restrained drying shrinkage and unrestrained drying shrinkage cracks. Okay. Patterns. Then these are cracks reinforcement due to reinforcement corrosion. You can see certain places the rust volume on the is shown high, and this is happened. Then this is a crack pattern due to alkali aggregate reaction due to sulfate attack. Remember alkali aggregate reaction, the pattern is more like a alligator scales. Now these are some important pictures. These are pictures of a cold joint. What is a cold joint? Already a column must have been constructed up to here. For the next level floor, again already hardened concrete column, again we put formwork and cast the concrete column. So in that case, this is already hardened concrete, this is the fresh concrete which later on gets hardened, and at the interface the joint is not proper. Okay, so uh, this creates a very weak bond. So these are called as cold joints. Next, this is a picture of honeycomb. Honeycombing is due to improper consolidation and vibration. The coarse aggregates, they settle at one portion of the concrete mix, and they produce when we finally pour the concrete and concrete hardens, and when we remove the formwork we see this defect, honeycombing. Then of course plastic settlement cracks. As we know, concrete settles in the fresh state, and if reinforcements are obstructing, then right above the reinforcements the concrete which is beginning to set, they split and forms cracks like this, parallel crack pattern plastic. This is scaling of concrete, can occur due to various conditions, weather conditions or improper surface finishing. Then scaling and dusting of concrete. Okay, in typically cold countries, this may be reason. The reason can be freeze thaw cycles and application of de-icing salts, which cause problem. Then these are crazing cracks. Crazing cracks are very fine cracks, like a small coin you put. You know, it's a very fine, shallow crack spread all over. This is due to improper finishing, not taking care of the bleed water properly before finishing. Now, drying shrinkage cracks. Drying shrinkage is the hardened concrete over a period of time shrinks, and you get a drying shrinkage crack. You see. So this is a drying shrinkage crack which is discontinuous. Again, this is a drying shrinkage crack at two edges of two. Drying shrinkage started here, and then they, as they grow, they join. These are called as control joints. Next, at the re-entrant corner, crack is developed. This again uh, due to reasons such as drying shrinkage. Well, it is typical at corner, re-entrant corner cracks. Then we have due to creep cracks. See, this is like a small retaining wall kind of a thing. Okay, this beam, it's trying to retain the earth or soil here, and there's a tree that is growing. Naturally, over the period of years, the roots grow and try to expand, and the pressure is taken by this particular beam now, which is acting as a retaining wall. What happens over a period of time in sustained load, the deflection, here you can see, here we can very clearly observe that this seems to have mildly deflected already, and along with that there are certain cracks. So these are due to creep. Then there are differential settlement cracks. When ground, either there's sinking of supports below, if it's a upper floor slabs, or on the ground there is settlement of the soil. Here you can see this is example of differential settlement, and which have developed cracks in the masonry structure. Now these are crack patterns that can be due to alkali aggregate reaction, because you can see the pattern is possibly alkali aggregate reaction. This is damage due to sulfate attack. They can be spalling and other things, but a sort of salts come onto the surface of the concrete in sulfate attack. Okay, some efflorescence. So this again another crack pattern due to sulfate attack. Sulfate attack. This is naturally these are green vegetal growth, algal growth. So this is severe sulfate attack due to exposure of the pillar to seawater. So this, and this is due to reinforcement corrosion. Spalling takes place. You can see the reinforcements are corroded, they are rusted. So you see these are all corroded reinforcements are rusted, and this portion of the concrete has spalled. Then these are some examples of flexural cracks, some examples of shear cracks at the column. This is example of a shear crack again. So these are some of the pictures that a visual inspector has to take. So this particular in this class, the reference books that have been taken are primarily these: Handbook on Repair and Rehabilitation of RC Buildings, and Concrete Repair and Maintenance Illustrated by Peter Emmons. This the first portion of the lecture was based on this, and then a large of portion of the lecture was based on Guidebook of Non-Destructive Testing of Concrete Structures, a training course series number 17. So this book is freely available on the web. So this was today's class. We discussed on the NDT methods, the scope of the NDT methods, and what visual inspection method involves. Thank you.